Let me introduce myself. I'm Angelo Crabstick. I'm out of the Johnson Space Center. I'm with Aerospace Education Services Project. So if there's a website you need to know, aesp.psu.edu. Okay. Oh, nice.
Yeah, I'm recording you for Stephanie.
Oh, okay, for Stephanie. All right, great. Okay, so if you stick around on that website, what you'll find out is what we do, who we are, what kind of programs do we offer. So we offer webinars, and those are just open Mondays and Tuesdays, okay? Okay, like for example, on May 6th, John Weiss is going to be on twice. We're on Eastern Time, 4 to 5 p.m., 6 to 7 p.m. And he's on the 6th, I'm on the 7th. And just join the webinar. Click, and you're in. Okay. Whoops. Oh, they haven't closed. They didn't leave it open. Okay. All right. I have the passwords to get in. Generally, what we do is you'll find details. So if you wanted to participate, we tell you in advance what materials. Most of the time, people just come in. Okay. And what I'm going to be doing on the 7th, I'll be doing 2 of them. Foam rockets, rubber band powered rockets. I did that with yesterday's group. Custom workshops, okay, in person or via the web. How do you submit a request? Okay, so we have an electronic form. Okay, so who the person is, and informal counts as just as much as formal education. Okay? And so are you a teacher, okay, administrator, homeschool, other museum staff, okay, email address, a little bit about the organization, okay, and what state are you in? That will route it to the center that serves your region. Now, the other thing that we offer is, are you working with a specialist? Okay, and that person may not be in your region. Okay, like I'm working with a group in, for example, in Las Vegas, Nevada. Okay, and that falls under another center, another specialist. And there was somebody that I knew, and I planted the seed, and it's growing, and it's getting exciting. I will come in as an electronic presenter. The specialist out there, Tony Levitt, he'll be there in person. So we're kind of working things out. Okay, and I just planted the seed and backed off. Okay, and now it says, can this be presented through distance technology? Okay. And that's probably how we're going to best support it, unless there's enough work to justify the travel. Okay. And I'm getting at the end of a 2-week road trip. And I've been up in South Dakota and work in Kansas, and then I'm going to be flying home. Right now, my travel budget's been reduced 60%. We've had a reduction in force. We're down to 1 specialist per center. And I don't do too many out-of-state road trips. Once in the fall, once in the spring, once in the summer. Texas is a very large state. I can get around it with a rental car, high population. So there are a lot of things that are driving this. So you just put a description, okay? And again, we ask again, can it be done online? Now you're asking for a little bit of our time, and I can present from just about any location in my office. Okay, I've presented in hotel rooms when I'm actually out on the road, and all I need is good high-speed connection and number of participants and so on. Are you flexible? Okay, and then you just click submit, and it goes through the approval process. So that's a little bit about what we do. If you look at the centers, okay.
On the webinars, once you're past that time, that information is no longer available, or is there a way to?
It's no longer available.
Okay.
A lot of them we do repeat.
Okay.
Okay, but now you can request a customized webinar.
Okay.
We want some numbers. Okay, they don't all have to be at the same location. Okay, because they can come in from anywhere. And here you can see I cover 8 states. Tony at the West covers Alaska and Hawaii. I believe he has the most. He has 10 states. Okay, so we're pretty busy. Okay, in person and online. Okay, here's all the different centers. If you click on people, you'll find who we are. Okay, as individuals. Easy to contact us. Click email. Okay, so we are available as consultants. Right. The programs then are webinars, in person, online. We're starting off what's called teacher learning journeys. So we're getting into the concept of digital stamps, digital badges. We're going to be doing, we're going to offer some webinars with this, but essentially some of the best activities. We have different strands and you can mix them up. We have some engineering, we have some rocketry, we have some astronomy, we have some earth science, and you would post your work, okay? And then somebody's going to be, grading it, okay? And at the end, you'll get a certificate. The certificate will have the amount of time that it took to do that. So we're working out, okay, this takes 3 hours, okay? And you post your work, okay? And there'll be a minimum to do to get a stamp. A badge, you got to do more, okay? And it's either working with students or, formally, informally. And we're all set to kick this off. So I don't know if you've ever come across this concept of digital stamps and badges. Okay. It's big. We're not the only ones doing it. That's what we have to offer. Okay. Now, my office, and here I'm going to open up my office, okay, and I'll just log in, okay. And you would come in as a visitor, as a participant, which means you won't be able to do as many things as I can do. And if you were hosting an event, whoever the specialist is that's working with you, depending on our high-speed connection, we're wireless. Caps, no, we don't have caps. All right, one more time. That should do it. And I can change this layout just so that you can see what this looks like. Okay, here, let me close that part off. Okay, as a presenter. So I have a camera. I can get my camera going. So now you can see me. Okay. Today we were doing Lego NXT, and what I've created is a download pod. And so imagine doing an electronic handshake in advance. So now we're comfortable with the technology. It's just a URL, so there's no firewall issues. Okay? If you don't have administrative privileges to load things onto your computer. Schools have a firewall. It's a URL, you just come right in. Okay? And so if myself or anybody else, download pod, whatever I highlight, you see where it says download. Okay, so you can either select them separately or select them individually. And The software is called Adobe Connect. It's not free. Okay. And so my employer's paying for the software. Okay. And what I like about Adobe Connect is when you download it, it zips and it compresses it. So you have, I think everybody's familiar with zip, okay, how to uncompress. So it cuts down on your download time, okay. And I can open up different pods, okay, and I can make my camera as big as I want, okay. And so, at your end, okay, what would you need if I came in as an electronic presenter? Well, they need to see me, okay, whoever the presenter is, okay. So you're going to need a projection system. You're going to need some speakers, a sound system, okay. Do you need a web camera? That would allow me to see the group, not necessary. Microphone, we can have a dialogue. But if you don't have a microphone, I don't know if you've noticed what I had over here, a chat box. So people can text in their questions, okay? Things like raise your hand, okay? And I could ask a question, and then you can state whether you agree, a yes, or a no. Okay. So it's great stuff. And I can open up other windows where I can ask a question. So I can offer a pre-test. Okay, so if I had a question when you signed in, what is a robot? Okay, and I would like everybody contribute some sort of statement. So anyway, that's just a little bit about what that is. All right, now let's get into robotics. Okay? And what I'll probably do is make a download pod, and I'll give you my URL so that you know where to download it. Okay, let me get into robotics. Hands on robotics. No, that's not it. All right. And what I want to do is just briefly introduce robotics. Okay, so the question is, what is a robot? And the most common answer of students is beats me, I don't know. Okay, and if we look up here, okay, the origin of the term, it comes from the Czech word robota. Yeah, Mallory, I don't know if you want to put that camera up there on the PowerPoint. Okay. Okay, so it's Introduction to Robotics, and we'll certainly make it available. Is she online right now?
No, I'm just taping it for
Oh,
her.
okay, you're taping it. Okay, Czech word, robota. Okay, Karel Kopik in 1920 was a Czech writer, and the play he wrote is called, known as RUR, Rawson's Universal Robots. Okay, and like I say, I'll make the PowerPoint available for you. Those
okay.
Go ahead, take notes. Take
Okay,
notes.
that's fine.
Good.
Yeah.
Okay. I hate to give away the play, the punchline, but I guess it's better. Okay. The robots, okay, human mechanical machines, okay, and he turned to his brother who was a painter, and he said, what should I call them? So we got a writer and a brother who's a painter, and his brother just sort of, I don't know if it's an urban legend, okay, said robota, which means repetitive labor, okay, and because they were working on an assembly line, Rawson programmed them to have human emotions. They revolted. Rawson deprogrammed them, and it was a very violent revolt. So you can imagine what was Europe like in the 1920s? Experience with socialism, okay, and they imprisoned Rawson, and they tried to make him reprogram them to have have emotions, and he didn't. So that's the origin of the term robot. Okay? All right, now let's get into the formal definition. All right, and I hope you like my humor here because I've gone different places to get these definitions. Okay, mechanical. Doesn't have to be electronic. Okay, what were we calling machines before they were powered with electrical power? They were steam powered, they were water powered. Okay, and we had the word machine. Okay, but mechanical or electrical mechanical device, does it have to look like a human? No. But it's capable of performing a variety of often complex human tasks on command or by being programmed in advance. Okay. Another part of the definition, it must operate remotely. Okay, remotely, and I'm going to give you a test. Okay, a machine that it's when we say it's under on command, okay, or programmed in advance. What we're talking about, okay, operating on its own, it's autonomous. The word we use for let's see, by remote control. Okay, teleoperated, it's under human control, programmed in advance. We use the term autonomous. Now, this is a definition I found in Webster's dictionary. I love this one. A person who works mechanically without original thought, especially one who responds automatically to the commands of others. That would not be accepted in a engineering class.
Okay.
That's just some humor. All right, so now you got an idea about what a robot is. Okay, now what we were doing today, we were using robots that are electromechanical, and we were just getting into programming them with sensors. Now, the neat thing about a sensor is now you can interact with your environment. So we got into robotic touch, and then we ran out of time. Tomorrow we will we'll get into robotic vision. Okay, we're going to have a sound sensor so it can detect the intensity of sound, and also it can speak as well. So sensors give you more information. Okay, and actuators, well, that's electronic motors. Okay, and again, we put our robots into two types of categories. Okay, autonomous, pre-programmed in advance, and they run on their own, and then teleoperated. That's our fancy word for human control. All right, famous robots. TV, movies. Okay, Rosie, Jetsons, and a couple of years ago, California had a governor. Yeah, and they were calling him the Governator. Okay, and this, of course, is from the movie The Terminator. Okay, and then I don't have all the robot movies covered, so give this to students and get them to improve it. Okay, that was Rodney Copperbottom, a Pixel movie. Okay, what was it called? Robots?
Yeah.
Yep. Okay.
That's iRobot.
I wrote yes. And the character?
Will Smith.
Sonny.
Oh,
Okay.
I've never seen the movie. I just know Will Smith is in it.
Based upon stories by Isaac Asimov. Oh, remember that name. We're going to get into that. Okay. In the private sector, Honda has Asimov. Asimov has a gyroscope. Asimov can run 6 miles an hour. Asimov can do stairs. Okay, closely behind Honda, and I really need to update this. Toyota. Toyota is working on robotic assistance. Okay, and now they're getting into the area of robotic hands. Okay, and Honda still has that edge. Okay, but different companies are going in different directions to try to capture the market. Okay, that's from a TV show, earlier based on a movie. Okay, well, probably one of the most famous robots of them all. Okay, all I'm going to give away my age.
I was
Okay,
gonna say, it was before my time.
Do you remember Lost in Space?
Yep.
The TV series?
That was before me.
That was before you?
I kind of remember a little bit, but I don't remember ever watching it.
Yeah, I saw it first run, now it's TV land. Okay, Robbie here has tractor treads, okay. But Robbie first appeared in, 1956, but before 1956, Forbidden Planet. And he had legs to walk on, okay. Oh, there he is, yes. It was color. As a kid, I remember.
Yeah.
See it. I was so young, my parents took me. Okay. And then 1952, they've done a remake on this movie. Okay, and it was what, 2006, and I forget who the actor is. You remember that remake? On the Day the Earth Stood Still.
Yeah,
Okay.
it was, wasn't it?
Well,
Tom
use your
Cruise?
cell phone, and or when I get you working, I'll Google it. Okay, and
I got this.
this is the
I think it was
oldest
Tom Cruise.
language I'm aware of in the universe from this movie, 1952. So there was this ambassador that came, okay, saying that humans are now you.
Keanu Reeves,
Yes, and what year?
2008.
2008. Okay, yeah, 1952. You got to see them both, okay? And I don't know if you're black and white's a treat, okay? But this ambassador came and said, if you don't change your warlike ways, okay, you're killing your own species. Now you're getting space travel. We're going to wipe you out. And here is the intergalactic policeman. That was Gorth, okay? And the words to stop Gorth from destroying the planet was Klaatu Barada Nikto. Now, the robotic fanaticists know this, okay? So if you're hearing this for the first time. Okay, and there it is, okay? Landed a flying saucer, and of course you know what they did. They shot him, and he was telling a little boy, Klaatu Barada Nikto, okay? Because he's programmed at a certain time, it's going to kick in. All right. James Arness was the actor, incidentally, in that one. Famous for Gunsmoke. Yeah. Oh, some of his early movies. Okay. So I can talk culture movies. All right. Now, this is a good example of cooperative learning. Do robots, are they working on their own? No, sometimes they will work together. You'll find robotic assembly lines. And probably the two famous ones, okay, of course when I was a student, if we had cooperative learning, it was probably cheating, okay, but now it's called teamwork. But there's R2, D2, and C3PO, okay? Now, when was the term robotics first used in the United States? Isaac Asimov, 1941, short story, okay, Liar, okay. He is famous for robotic laws, okay, and this is science fiction, okay, and he came up with a set of 3, and then he expanded it to 4, and everybody knew about them as the 3 laws, okay, and now you're going to cross out 3 and say, but there's really 4 laws. He had a way around it. Oh, what a brilliant man. Okay. Oh gosh, and when were these laws first in print? A story called Runaround. Okay. Oh, I wish I had first edition of this stuff. Can you imagine what they're worth? Okay. All right. Well, what are the laws of robotics? Well, law 1: a robot may not injure a human or through inaction allow the human to come to harm. Okay. Law 2: a robot must obey orders given by human beings, except where such orders would conflict. Law 3: a robot must protect its own existence as long as such protection does not conflict with the first or second law. And then later on he expanded on it and he called it Law 0. Okay. Robot may not harm humanity or by inaction allow humanity to come to harm. So robotics is in our culture, TV, movies, and comic books. I have fun when I work with elementary kids. And I'll say, all right, what laws of robotics are being broken in each of these comic books? Well, obviously, here's a robot imprisoning, okay, 10 cents. Wow, you can imagine, let's go way, way back. I'm going to buy a comic book for 10 cents. Okay, this is before barcodes. Barcodes are about 1974. And I got a kid at home that has about 900 comic books. Okay, and so it was very interesting when he found exactly what year, what month that barcodes started in comic books. Okay, now let's look at this one. Okay, looks like G.I. Joe and G.I. Robot, and the robot is protecting G.I. Joe. But look, there's an airplane attacking. Okay, I was in a classroom one day with fourth graders, and I had to zoom in so that we could see who was piloting that plane. If it was a robot piloting that plane, no laws are being broken. When we zoomed in, we saw a human pilot. Some laws being broken here. But remember, we're talking science fiction. Well, now we have robotics as only NASA can. We have rovers on Mars, okay, and they're autonomous, they're pre-programmed, okay. What's interesting is they have a camera, so they'll do a 360. The imagery comes to Earth. We have a Mars yard. We'll do a layout. We'll write a program, and we'll send it up, and then they'll do that task. Okay. We've built in, so for example, if it gets stuck and the wheels are spinning, it's not going to get stuck by digging a hole. So there's some feedback mechanisms, but it's pretty much autonomous. An arm, shuttle, an International Space Station, that arm's being operated by somebody inside the station. So that's not autonomous, okay? That's teleoperated. We have exploration of the solar system being done by robots. One-way trips. They're expensive. Okay. Pioneer 10, Pioneer 11, followed by Voyager 1, Voyager 2. Leaving our solar system, we've explored either by flybys, orbiting, or landers, 8 of the 9 planets. Okay. The only one we haven't sent a probe to yet is Pluto. We got one going directly to Pluto called Pluto Express. Okay. And these were designed to fly past a planet, and it's called gravity assist. So the gravity of that planet will grab it, fling it on to the next planet. Really awesome. We have some sample returns. So we have had robot missions where they've flown through the tail of a comet. Comet dust particles, and coming back to Earth. Okay, we had another mission where we were collecting solar winds, but don't think of it as atmospheric wind the way we have an atmosphere, but what the sun is putting out. So we have some solar particles. So we have a lot of ETs in our collection. Okay, extraterrestrial materials. All right, now what are we working on right now? Well, we finished Personal Satellite Assistant, which was a small sphere, okay, powered with little puffs of air that could move around. 2 cameras, which would give you depth of field, so stereo vision. Okay. We have some spheres on board International Space Station. We have a contest. Students write programs to get all 3 to be synchronized and move around. Okay, so we have that for both high school and college. Okay, and then we have Robonaut, and we invent words for the dictionary. Take the word robot, take the word astronaut, and this is the first humanoid robot built to work in space. Okay, and we have the 2nd generation. We call it Robo 2. So those are what's going on. Now, how about a quiz? Okay, remember those definitions I gave you? Is this a robot?
Well, it's
Mechanical.
Mechanical, good. Is it remotely operated?
It could be, but
Could
it's
be.
probably automatic, or, you know.
Sure, okay, right. It's remote. Well, either under human control or pre-programmed. All right. How about this? There's no electronics to this one. Strictly mechanical. Is it remote?
Yes.
Operated.
Yes. Yeah, down here and it's gripping at a distance. So that's remote. Okay. Designed to do a task. A pencil. That's a lever, incidentally. Okay, you can see where the fulcrum is. Okay, pivot. I'm applying effort here. Okay, so do I get that right? Oh no, okay. Wait a minute. I think the fulcrum may be back here. I'm not sure. I have to work on that one. I think that. When I talk about lever, there's 3 classes. Okay, but you can see where it's pivoting and I'm applying a force. Okay, but now is this remote?
No.
No, it's in my hand. So although it's a mechanical device, it is doing a specific task. It's not a robot. Okay. I pull things off the web. Okay. That was before I got married. She said, yeah, we're remodeling the kitchen. Okay. But anyway, you put in the coffee. Okay. You put in the water. You press the button, and you walk away. Is that a robot? It's doing a specific task.
It's
Is it
mechanical.
operating remotely? Yeah, it is a robot. Okay. A slinky is a toy. What does a toy do? You play with it. Okay, it's not a robot. All right, well, one of my colleagues, John Weiss, okay, he does, what I do, I call robotics without electronics. He does one he calls robotics on a budget. And I got this idea from him. I tend to go more into the literature side and so on. We just swap ideas and so on. He got an email from a teacher who said, I put a Post-it note on it. And I wrote on it. And I sent it down the stairs. It's gravity driven. Okay? So it is delivering a message. Is it a robot now? The answer is. What do you think?
It still doesn't, you don't operate it remotely.
Well, it's going on its
On
own.
its own. After
Okay, yeah, it's no longer in my hand. Okay, once I start it going,
Mechanical.
it's going. It's a robot. Okay, it's a robot. I start it, and then it's autonomous. It's going on its own. Okay, so at the beginning, it's under human control. Now it's remote. It's moving away from me, and it's doing a specific task. If I put a Post-it note to it, it will deliver a message.
Yeah.
Okay. If I buy it from Toys R Us, it's a boomerang. If I go to Australia, okay, it is a hunting tool. Okay. So, if you used it as a toy, it's not doing a specific function. It's not a robot. To an Aborigine, a boomerang. Okay. Designed to do a specific task. Okay. Starts off autonomous under human control. Okay. Or sorry, teleoperated. And then you release it, now it's autonomous. If it misses the target, it comes back. If it doesn't come back, it's called stick. Okay? There's a lot of science to that. There's some aeronautics in that boomerang. Okay? So that is a robot. Okay? It's an Aborigine. Okay. Computers do not qualify. Okay? Got a bunch of smart people got together trying to define things, and computers are just too technical. So if there's a computer, we just say, even though there are ways I can operate it autonomous, because they got those clickers and so on, right? We just do not consider computers to be robots. Okay, why use robots? Oh gosh, lots of answers. Okay, so they are used in warfare. They're for safety, education, manufacturing, exploration, other reasons. Have robots do dangerous work, hazardous work. And I was really surprised, okay, in Japan, okay, Oh, earthquake and tsunami at the same time. You want to really define a very bad day. Okay, and their nuclear reactors went down, and the fail-safe systems didn't work. Okay, they had fail-safe systems if there was either a tsunami or an earthquake. They never thought, what if we had both? And what they didn't have in advance, ready to go, was robots to go in there. Okay, and there were some people that probably going to have some problems because they went in and they were exposed to some high radiation levels. Okay, so send the robots in to do the hazardous stuff. Okay, to humans, they're expendable, and robots can have a very long lifespan. Okay. Pioneer 10 and 11, launched in the 70s, still going, still communicating with us. Okay, nuclear powered. Okay, because you get so far away from the sun, solar power doesn't work. Okay, do they have to be high tech? No. All right, so that's my short presentation about robotics, and I will have that posted as a download for you. Okay, let's do an activity. All right, let's do some real quick building. We can do these in any order that we want. All right, why don't we build our 3D finger, okay? And then from a simple finger, let's see if we can build a shoulder, elbow, wrist, okay, fingers. Okay, all right, now let me pull this one up.
You have a yellow finger.
And if you, I'm opening up the
The
guide.
science of food. Science of food. I think I'm being silly.
All right. Now, what it says to do is, if I built a bunch of fingers, I can make a hand, and if I just take an empty water bottle, okay? What's really neat is you get your fingers out of plane. You have opposable fingers, okay? And if I did that, I could probably pick up a ping pong ball or a large marshmallow. Okay. But now let's. You can see our graphics. It's very, very simple. And what we've given you is a template. So run this off on a hard stop. Okay. Now, if you read real carefully, what it says to do is to take this, keep this on the outside, roll it up to where A meets B. Okay, and let's get some tape out. Okay, and we'll get some scissors. Whoops,
Sorry.
Okay.
It was less coordinated than I had hoped it was before. I have 2 pairs of scissors. Ha
Okay, so you see where the lines are, where A meets B.
A meets B.
And here you can see, all right, so I've taped it up. And of course, when you're working with students, you may want to have props where they're built. Okay. So where A meets B, you can run the tape that way, you can run the tape around. Okay, you can really streamline it.
Tape is a bad idea for children.
It's better than glue.
I think children should just be locked in dog kennels until they're like 18.
The way,
Kidding?
Aren't you glad that you make your money with children?
I'm being sarcastic.
I know.
Oh, that's a pretty ring.
I know. It's because I spent my wedding ring at work one day and lost my stone, and I'm too cheap to get it replaced. Mom bought me that when Ashley was born because she was born on Valentine's Day.
So you gotta love baby.
I do.
okay, now I'm gonna go back to this one right here.
That's something
So
your
that
husband
you
should,
can see the
like,
steps.
cue up on it.
So you take the tube,
Fix.
Oh.
okay,
Oh,
Right.
my wing's broken. I should.
use a hole punch, punch the hole. Next, we're going to cut out those diamond shapes. And what you might want to do is pinch this, okay? And when you cut, all right, use the back of the scissors. Okay, these are two levers, first class. So effort here, pivot here, and resistance here. Okay, and it will cut better if you use the back, the base side of it. So you're going to squeeze that
You
diamond
can have video games. That's
in the middle.
technology.
Well, yeah,
Okay,
we always have.
and so that, okay. I know
You can
we
leave the
have,
arcade open
we're
for you.
videotaping
Well-
this, so I should show this up close. Okay,
Last year, we'll have to post
and
some
here you
pictures
can
on the
see
break
where
room.
we've taped it. Okay, now we're gonna pinch. Okay, and you can see where we've cut out the wedges.
First one.
Okay, we're gonna use a single hole punch, and we're gonna punch that hole right there. And then we're gonna get some string. Yeah, let's pass out some string.
I'll get it untangled.
Okay, yeah, I think this is just about the end of the line of this string here. Okay, so just go ahead and, the
I'm really
string.
good at untangling yarn knots.
Oh, okay, yeah, don't worry about that, I'm getting enough here. When, it usually happens when I get to the end of one of these big balls, they all of a sudden begin to.
You get yarn barf.
Yarn barf.
Yarn barf.
Oh,
That's what I call it.
is that a mechanical device?
No. It's just what I call it.
Designed
'Cause
to do a
my yarn
specific
does that.
task,
It's a bite.
and is it remote? Okay.
So are you guys working on your silver award?
No.
No.
We had several things in mind and it just didn't pan out, so we can still do gold as long as
How
we
many
do
yards does
two
spring
journey.
You don't need too much.
As long as you do
Okay,
two journeys.
all right.
Yeah.
No, it
That's all
doesn't
we're in.
say, okay, but now look at this, where you push it all the way through, bend it, okay, flex it, okay, round it out because you've kind of flattened it a little bit with the diamonds, anchor it by tying it, okay, and then when you pull, okay, you can see how this will operate. Just like a human finger. You just got to get it down through there. There's a three-dimensional finger.
How many girls are in
There
your
you go, right, there's all,
Three.
yeah, Gail, there's all kinds of
Is it
techniques to get that through
Mackenzie
there.
still in your
Yeah.
Mackenzie, Rochelle, and Ashley.
There's
Hey, come on in, yes, we're doing our 3D finger. We're also recording, because
recording
there's
for
one
Stephanie.
person who couldn't make it.
Well, no, I'm recording for Stephanie.
Oh, she called you. Sorry. I've been upstairs. I never got to dinner yet.
Oh, okay.
We're getting ready to do our balloon flight. We had some.
Oh, you're doing a night flight.
No.
Oh,
We're getting
oh,
ready
preparing
Sunday
for
morning.
tomorrow. Okay, will we see you tomorrow, doll?
Yeah, I'll be fine.
Okay, good.
Are you flying tomorrow?
No, we're flying Sunday morning.
Oh, okay. We'll
Well,
catch you morning or afternoon?
Huh?
And we do have a presenter coming in as well.
You do. Joe Crinian, he's been before.
Okay,
He's going to be
Good.
here about 11:30. Looking around, Joe.
All right.
Okay.
Did you
Um,
tie
okay,
that?
anyway,
No,
yeah.
I just put it up and then taped it. Yeah, that's what I thought.
well, tape it or just tie a knot, yep. Now, I kind of played around, so if you look at this, I got some Velcro.
Yeah.
Okay, because I was thinking, well, we're gonna try and pick something up. Now, what I can do with two students is, I could have a small, just something, let's say a small candy bar. And can you work together to pick something up? So, and I was thinking, well, maybe tape some sandpaper to grip, yeah, and I found some of this Velcro. Looks good, but didn't really matter.
Yeah, I was gonna say, yeah.
Okay. All right, but now, when you look at the activity, okay, if you want to make a humanoid hand, okay, begin to tape them, okay? And if I was really gonna go humanoid, not all my fingers are the same length, okay? Thumb, you only see 2 external joints, and the third one is internal. So I would probably clip that off, okay? And begin to operate. If you tie loops through at the end of these fingers, okay, then I can put my fingers through the loops and help control it. Yep. And what you see right here is a wooden dowel. Okay. Now I can
Reach out with.
yeah, reach out. Now it's remote. Okay, and I could take 2 meter sticks and put a bottle at the end and have the fingers on it, and the strings back here, and I can really operate it remotely. Okay. All right. Questions? Okay. Good. All right. Great hands-on activity. And this is just fun at all grade levels. Okay. All right, now, the next activity we're going to
Oh,
do
wait, I got this one.
is we are going to build,
Haha. But it actually kind of hurts. The color, it also looks like a French fry.
So you could,
My-
you could
my-
taper
I've
it.
Or
got
like a
some
worm.
paper.
You could
What's that?
taper
I got a
it, make like a fingernail.
well, depending
Suck it
upon
in,
how
so then it
careful you cut the diamonds. Now, if it doesn't spring back, I'll take a number 32 rubber band and I'll cut it and I'll put some tension on the back side and it'll help.
You can
spring
put
it
that on
back
the
up.
outside.
Yeah, on the outside. Sometimes
So
I'll
it wants
run
to run
tape
back
all the way
somewhere.
down so that you don't see it. But here, let me just show because they're not there.
Oh, yeah, you can
Okay,
see
you
it.
can you see that rubber
Yeah.
band?
Okay.
And so if you cut that diamond out too deeply, it's not going to spring back. Now,
That's what I did.
oh, okay, yeah. Well, in one of those, okay. Well, a rubber band. Here you go. Yeah, cut that and stretch it on the back side. It'll help spring it. Now, in terms of musculature, okay, we have muscles that will close. These are called flexors. We have muscles, oh, it just went to sleep, okay, that will open. Those are called extensors. So my flexor is when I pull on that string. Okay, and it has a little bit of memory, or you put a rubber band, and there's my extensor. So now I can get into human anatomy, human physiology. Okay, can you tell me the bones? Can you tell me the muscles? There you go, right. The ligaments. Okay.
I'm gonna go back to making my house cleaning list. Okay. That's really what I was doing.
I got some tape already cut.
Okay, the Crabstick challenge. All right, I go out and I buy jumbo Crabsticks, not the standard ones. Okay, and I'm going to use brass fasteners. And I'll look at the width of the brass fasteners, and that will determine what size drill bit I will use. Okay, and generally your brass fasteners, you don't want to exceed 1 inch because as they get longer, they're wider. And I used to be able to find 1/2 inch. They're the smallest. They don't stock them anymore at Office Depot, Office Max. I go to a stationery store. You go to Walmart and so on, and I'll find the 3/4 inch and 1 inch. Okay. All right. So I'm gonna pick a diameter here. This is a pretty old drill
Got
here.
a key.
Yeah, right, yeah, it has a key chuck, very good, right. Right here. All right, customized. Let me find my brass fasteners.
Forcefully.
And so what I always like to say is inexpensive, mostly local obtainable materials. Okay. Now, we need to find somebody that has a drill press in their garage. They'll drill the sticks for you. Okay, but now,
No, I'll
If-
say I'm gonna use.
I want
my
you to
drill.
see that I'm gonna come up
Go
close here.
through.
Okay, so that
Oh, okay,
you can
made
see
like
that.
a little-
All right, yeah, I made a jig, okay, and there are markings where I'm gonna be drilling 3 holes, and I can stack them up. Now, what I don't wanna do is drill through and
They
put
would
holes
hurt
in
me.
tabletop, yeah. That would be very bad, okay. And then the new guy who would be coming next would tell everybody how much he likes the job. Okay, so what I'll do is set this up, okay, so that, let's say I'm not gonna drill through the table,
Okay.
okay? I like to use cardboard rather than wood so that I'm not wearing out the drill bit, okay? And when we start looking at the brass fasteners, okay, that comes pretty close. And you might have to do a little pushing to get them in. Okay. You could pre-drill these in advance, Ziploc sandwich bags, okay? So 4 craft sticks, 4 brass fasteners, and you are going to make an arm that will extend, okay? So there'll be a shoulder and an elbow, and if we used any plastic forks or spoons and so on, we can put fingers. We got a name for fingers, they're called end effectors, which can be very, very specific depending upon the task. So I just grab a bunch of sticks, I stack them up, okay?
You're gonna kill a lot of sticks that won't survive.
Got to really have a good grip on them, or you might crack a few of them. Kind of takes me one to sort of warm up. And I let the drill do the work. Well, let's see. Bad. Okay, here we go. We got a couple. Wow. 1. Oh, I only got 3 out of that. Okay. Takes a while to develop the technique. Okay. The other thing is that I'm sort of cantered here.
Let me help you.
Yeah.
All right, good. All right, volunteers. I tell you what, you want to do the drilling?
No, probably can't.
Oh, good answer.
Wouldn't be the
Good
first
answer.
time.
Okay. All right. You wanna? Okay, go ahead.
I gotta have it. I'm not my game.
Okay. All right. You see where, right there.
So right.
Yeah, right in the middle. There you go.
Boy,
Go
you
ahead.
girls just like Ashland. Or Ashland is boy, you girls.
Good. Now go to the middle one.
About right.
So
Yep.
what does Ashland do other than Girl Scouts?
And then you wanna go to the end.
She sings in choir.
Oh, we got.
Oh, no, that's
That's
okay.
about it for school.
All right.
She likes to read, just getting where she likes to
It
read.
doesn't matter. There you go.
She's a TV junkie right now.
Okay, wow, let's see how well
She
we did.
discovered
Oh,
Netflix,
bad.
so
okay, well, yeah, you
It's
get
cheap.
the
it
occasional
is.
ones that are
The bad
cracked.
thing is, last summer she discovered Saturday Night Live.
These are very
so-
inexpensive craft
So
sticks.
she, her Will Ferrell is
Okay.
her favorite.
All right,
She has
yeah,
good
all right,
taste.
so here we go. 4 sticks,
Except I'm a bad mother thinking, oh yeah,
Okay.
campaign's all her, it can't be that bad, is it?
Right.
You
Pass
Yeah,
out
but it
four
was
brass
horrible.
I
fasteners.
know, the very
Horrible,
first scene,
horrible.
it's like, ah!
Okay, 4 sticks.
Oh.
And another 1, 2, 3, 4 brass fasteners. Okay. All right.
I don't need them.
that's-
I don't need them. You can just
Oh,
make
okay.
two
All right.
sets.
You go ahead.
I've done it before. This one isn't as entertaining to me as
The finger.
the finger. Oh, well, like I
Okay.
always make a foam rocket because I really like making them. We currently have one that's flying around the office because I gave it to one of the student employees,
Oh,
and so he shoots it off when he doesn't have anything to do in the office.
No.
I created a monster.
Now, you can start off with okay, 2 sticks, and what you can show the kids, what are the different ways that I can attach? Okay, when you talk about a lever, there's 3 things. There's the fulcrum, the pivot point. You apply a force, and then there's resistance, there's the load. Okay, and try this one. I think this is one. Right there. Oh, yeah, okay. You know what I do with a lot of these? A little bit of masking tape.
Yeah.
But I understand how students are. Okay,
Yeah, some students are very picky.
right.
I used to want to break
And
before I get home.
informal evening educators, yes, okay. I'm sorry. Okay, but
They're
now,
your students tonight.
okay, look, this lever, everybody recognizes the
Teeter-totter.
teeter-totter? Right, okay. With the fulcrum in the middle, apply an effort at one end, there's a resistance or load on the other. That's a first-class lever. A second-class lever, the fulcrum moves to the end. Think of a wheelbarrow. So there's my resistance, the load in the middle, and now I apply my force at the end. So you see where the position is. The third-class lever, and you can look this up, okay, is I'm going to switch the positions of where I'm applying the effort and where the resistance is. The fulcrum will be at the end. So if I was playing tennis, all right, so I'm applying the force somewhere in the middle, okay, and then the ball will be, the resistance. Okay, there's a fulcrum. Baseball, golf, fishing, oh gosh, all my favorite games. Okay, so that's third class. All right, but now what you're doing is you're going from a simple machine to a compound machine, several things. So now, can you make an arm? Now, I know we're under a time crunch. You don't want to show your students, okay? Now, if you say, don't show me, would you like to see some solutions?
Mhm.
All right, so we'll move on because we're kind of in the time crunch. All right, look at this. So, wrist and end effectors, elbows, shoulders. Okay? All right, now is this a robot? It's designed to do a specific task. It is remote
It's mechanical.
and it's mechanical. They're not electromechanical. And what I like to do is, gosh, I didn't bring any with me. Okay. Oh, well, if I had some spoons, then I could, put them on. I can trim the end of the sticks. I love to put 2 forks on it like this. Okay, and that, now let's go to the Chinese
On the
restaurant.
dessert.
Okay, and that is my robotic chopsticks. Okay, so there
I just
are
think
ways
that's
that you
Spaceballs.
can give them something and give them a challenge. Maybe it's picking up a ping pong ball. Okay.
So a pair of chopsticks is a robot.
Yes. Mechanical.
Right.
mechanical device designed to do a specific task,
Remotely.
and you're, you know, and it is remote.
Remote.
Yes.
I'll never look at chopsticks the same again.
Okay, now let me show you another solution. If you notice, this arm only goes straight out and straight back. Now you have a wrist, right? Okay, so I modified this. Now I have a wrist, so I can go, that will move left or right. Okay. Came up with another solution. Okay. And remember, when these crossed, now they don't. Okay. What I like about this, if I grab something and I'm holding on to it, okay, that's a lot easier than, you know, holding on to it like that. Okay. So there are lots of solutions, okay, to what we call the robot arm challenge. Okay, and a lot of these are not published. Okay, they're not published. But I you know, I've given you printed copies,
John Barf.
and I'll make some copies for you. Okay, let's see, where are we with our? Okay, how are we doing time-wise?
It is 7:49.
7:04. Just a few minutes behind. Okay, I haven't shown you the video, Robonaut. Let me do closure with this video, okay? And it is an awesome video.
What else can you do? I'm making thinking about locking things for you.
Okay. Oops. Hold on. It's a
You could do
talkie.
like putt-putt. Because that's both like math and engineering.
Yeah. Cause I think they had like, what do they call it, hillbilly golf or whatever.
I guess I can't we did one summer. I don't have the curriculum because I couldn't keep it. But they had to make a putt-putt golf course and use gold medal, aluminum foil.
Let me get my external speakers. Okay.
Robonaut is a teleoperated robot, meaning that a human operator can control its movements from a distance.
Okay.
The teleoperator wears a
Let
head-mounted
me get out of it and then open it up again. As I just turned on external speakers.
In classic science fiction, authors and artists dreamed of an age where humans would work side by side with robots, mechanical helpers that were so advanced they resembled their human creators.
Okay, how's
Was
that?
that age so far away? At the NASA Johnson Space Center in Houston, Texas, engineers have taken the next step in robotics. This is Robonaut, and it's not only changing the way people think about robots, it's making yesterday's science fiction a reality.
Okay. Under human control. Teleoperated.
Robonaut is a teleoperated robot, meaning that a human operator can control its movements from a distance. The teleoperator wears a head-mounted display to both control the head of the robot and to see what the robot sees. The binocular video on the helmet's displays give a sense of depth and worksite immersion. A position-sensitive glove controls the movements of the intricate Robonaut arm and hand, which replicates the capabilities of a human arm and hand. The human aspect of the robot hand gives the Robonaut great potential to be an assistant to astronauts working in space. The current hand has 12 individual controlled motions, or degrees of freedom, divided into 2 sections. The first two fingers and the thumb make up the dexterous work side. They have 3 degrees of freedom. They can open and close, as well as spread apart, essentially like human fingers. The remaining 2 fingers only open and close. They are used for grasping. The palm can cup to help grasp tools. With over 100 sensors in the arm, the manipulator has a fine motion capability that equals its great strength. The arm's 1-to-1 strength-to-weight ratio is unequaled in the commercial manipulator world, allowing for the portable and mobile applications that Robonaut faces. The endoskeleton is designed with custom space lubricants and materials to meet the extremes of the space environment, and is covered with a novel skin that will protect the arm and help make it safe for its role as a human assistant. The 2 arms can work together to perform more complex tasks, to hold large objects using both hands, or to stabilize and work on objects simultaneously. Robonaut's upper body is mounted on a 3-degree of freedom waist, allowing full orientation of roll, yaw, and pitch motions. This articulation of the torso allows the robot to extend its reach and position its dexterous pair of arms for efficient worksite
I think the door is
operations.
unlocked, Angelo.
With a range of motions greater than that of even a human gymnast, this waist can rotate fully around, repositioning the arms for work and the head for inspection. The head, still in development, houses stereo vision cameras that are pointed by an articulated neck. As the operator moves his head, Robonaut's eyes are pointed to mimic the human's gaze, with the binocular video on the helmet's displays that give a sense of depth and VR immersion. The head contains an additional pair of cameras with auxiliary view angles and LEDs that can be used to illuminate the worksite in low lighting conditions. Robonaut's design could be ideal for helping astronauts because, for the first time, humans and robots can share the same spacewalking tools. From this power drill, used to represent the space torque wrench typically used to loosen or tighten bolts on space hardware, to tethers designed for human hands, which are used by astronauts to connect themselves to a spacecraft, and Velcro strips used to attach thermal blankets and insulation covers. Construction is underway on the International Space Station, the largest space structure ever built. The space shuttle robot arm has been invaluable in helping astronauts to move the giant pieces of the station together and maneuver spacewalkers to their work sites. The space station will have its own robotics system designed to help build and maintain the giant structure. Robonaut has the potential to expand the role of robots as helpers during routine maintenance tasks on the space station. The robot could be used to set up a work site for the astronauts, installing foot restraints, for example, saving valuable time before the complex spacewalk actually begins. As the astronaut works on the station, the Robonaut could act as an assistant, much the same way a nurse works with a doctor. Or, if desired, the robot could perform some of the maintenance tasks on its own by being teleoperated by an IVA astronaut. When the spacewalk is complete, Robonaut could stow away the same equipment it set up earlier, freeing the EVA astronaut to perform more important duties. Robonaut has applications not only in the maintenance of spacecraft, but also in the exploration of other worlds. The Robonaut torso could possibly be combined with a rover, allowing travel across the rough terrain of other planets. Imagine the ability for a geologist to survey Mars through the eyes of the robot, then use its hands to scoop up soil, or even pick up a rock, inspect it, and add it to a collection for return to Earth. In the future, the same Robonaut technology that helps explore space could also have some very down-to-earth applications. Robonaut's sophisticated hands can work with tweezers, pipettes, and a number of other common handheld tools that could be used for a host of telescience applications. Whether the Robonaut works on its own or just lends a helping hand, the uses of the Robonaut are limited only by the imagination of its user. No longer reserved for the pages of science fiction, Robonaut represents technology that is working today, with far-reaching applications in the future, both in space and here on Earth.
What do you think of that video? Okay, Robo 1 has been replaced by Robonaut 2. 1 was just ground. 2 is now on board International Space Station. Quite a jump in technology, because if you notice on that one, when he put on the gloves, it was wired. Now we're wireless. So infrared, so they can send the signal, okay, throughout International Space Station. And it's now on board the station, and they're doing some basic tasks with it, okay? We do have a website. So if you take a look at our evening workshop agenda, okay, there's the Robonaut 1 and 2 websites. If you want to find this one right here, exploration timeline of robotic firsts. It shows all the NASA missions, okay, where we've sent robotic explorers. We're going way, way back in time, okay? And so kids can really research it. We're doing a lot of Mars robotics exploration. There's an Explore Mars homepage. So I'm giving you a lot of URLs, okay? And I'll just go to one or two of them very quickly, okay? Here, I'll click on that. That should send it. Let's see, control, yeah, there's that hand. Okay, so here is the Robonaut homepage. And that video I showed you was Robo 1. There's a lot more videos, and I was really looking for a good video that would capture. Okay, the Robo 2 are neat, but I really like the way Robo 1 just rolls it all on up. And if I go to Robo 1, okay, and if you want to really get into robotics, click on subsystems. Oh, you see Robonaut on a driving base, okay? We call that Centaur. Think about your mythology. Believe me, I make the connections to language art and probably Western civilization. Okay, but what we have is I can go system by system, hands, arms, okay, the head, okay, and you could run these off and have the kids do some reading. Okay, I know the reading level is a bit high, secondary reading level. If you click media, okay, that video that I showed you, they broke it up into smaller bites. Okay, and to use video, the government has to make it 508 compliant. And so if I have people that are hearing impaired, you have a script. Okay, so that's how I can share that one with you. Okay, some great stuff on Robo 2. Okay, so great website to go to. One more website, the one the timeline on robotic firsts. Okay, let's take a look at that one. So look at this timeline from past, okay, starting in the Sputnik 1, Explorer 1, okay, the present, okay, oh, okay, so you just kind of hit this, okay, and if you scroll over any of these, okay, it gives you the name of the mission. You click, it will take you there. Okay, so robotics is only NASA can. So I'm just, believe me, you will keep students engaged. So, and then there's a few other, sites I gave you. All right, now I'm looking at the timeline. I think we have time to do one more. Okay, and what we're going to do is everything we've been doing is humanoid. So let's pick a non-humanoid. Okay, I think what we're going to do is we're going to build rubber band powered rovers, and you're going to have to adapt them to see if you can make them move across the room. Okay, the educator guide I'm going to use is called On the Moon. So let me go ahead and open up that educator guide. Yeah, you want to hold your hand. Um, I gave you the handout and I showed you that cardboard
Yeah.
one. It's pretty intense, but I have it as a kit form if you want to take it home. Let me just take you through this and we'll take whatever time's left over. We'll have a dialogue, okay? And let's see, On the Moon Educator Guide. And let me get out my On the Moon handout. Well, I always like to give people the entire guide, okay, with several activities so that you can do more. So rather than just tease out one activity, I want to show you where, you really like this, you can continue on. So On the Moon has 2, 4, 6 activities. Okay, there'll be a section for you as the leader, as the teacher, and then there's a section for the students. So let me page through this. And these are what we call engineering design challenges, okay? Which means what you're going to do is you're going to build something that's never existed before, okay? The difference between science studies the world as it is. Engineers create the world that never was. And I am quoting von Karman, okay, who was a Polish engineer that came over in the 1930s. And then he started working with NASA. And he was working at Jet Propulsion Laboratory at the West Coast. It's a very, very famous quote, okay? And if you want that quote, I'll pull it up, okay? Once I get you working. Okay. All right. So On the Moon Educator Guide. Okay. Several activities. Now, if you're not familiar with the engineering design process, this is what it is. You brainstorm. You come up with a design. You build it. And as you're building, you can change it. The scientific method. You come up with a hypothesis that you'll prove or disprove. You're identifying independent variables, things I can control. And I just pick one and I change it, okay? And then the dependent variable is the beats me, I don't know, what's the outcome? And so there are 2 different approaches, okay? 2 different ways of accumulating knowledge. So that's how I distinguish between the 2, okay? And I'm not sure what grade levels you're working with, okay? Here we can see how to use this guide. That roving on the moon, the rovers, they say grades 6 through 12, okay? And they're based on real missions. So you have websites if you want to go to those real missions, Lunar Reconnaissance Orbiter and Lunar Crater Observation and Sensing Satellite. Those are missions that were just completed recently. And let me flip through to roving on the moon. Now, when we look at this, here, let me zoom in so you can see this, okay? This is how you as the leader are going to introduce the challenge and prepare the materials in advance, okay? We don't show them this, okay? Or all they'll do is just copy you, okay? We want them to be creative, okay? The most creative, kindergarten, engineers, architects, okay? And they usually beat out school administrators, business majors, because business majors spend all their time coming up with a plan, not really testing it until they get to the end. CEOs don't do very well. They do better when their administrative assistants are with them. And lawyers don't do very well with these kinds of challenges because, again, there are rules. Okay, on this, okay, I don't want you to be bound by rules. I want you to be creative. Okay, and usually for creativity, elementary kids beat the engineers. They really do. Maybe not the best solution, but certainly the most creative solution. All right, now let's, you can see where, I'm not going to read to you, okay, but how it prepares you how to run it, okay, and there's some equations if you want to get into the equations. This is what you give to the kids. Okay, let me go Command L, and whoops. Okay, and this is the challenge. Oh, okay, it does give you some basic stuff. Okay, now look at the material list. Okay, and it's in the handout. Okay, I am going to give you a 6-inch body. So how am I preparing? I get cardboard. I'm in the teacher lounge. I'm using a cutting board. Okay, so you're going to need a 6-inch body. You're going to need 2 wheels. So now I'm giving you 2 5-inch square wheels. Okay. Hands on. I put all my effort into preparation. Easy to teach, okay, but it does take some prep time. Now, I'm going to give you a pencil for an axle. I'm going to give you 2 rubber bands. I'm going to give you 2 number 32 rubber bands. Okay, okay. You can use a straw and 2 lifesavers. Notice the wheels are disproportional. Now, I can't make something better unless I'm willing to change it. And I'm going to show you some changes that I came up with, okay, and brainstorming with my colleagues. Let's see, pencils.
They're on the table.
There we go. All right. So, pencils, okay, but rather than straws and lifesavers, okay, I was Hobby Lobby, Michael's, a craft store, and I can get wooden wheels. Okay, so I'm going to give you each wooden wheels. And the axles that I found were skewers. And because it's pointy, you might want to cut it off. Okay? And then, you know, when you punch and it goes all the way through, then you can cut it off. So it's your choice whether you want to go this way. Okay? Really works well. Okay? All right. So, customized. Yeah, we'll have time to do a little building. Okay? And gosh, with this, yeah, you can cut it. Now, you can use this for the front and wheel axle, or you can go with the pencil and straw. So don't be afraid to change an activity a little bit, because that's how, wow, hey, this works even better. Okay, and maybe it doesn't take as much time. Okay, all right. So, oh, and then, oh, you need motors. Okay. So I have some number 32 rubber bands. Okay. All right. Now, if you built it like that and tried to make it go, it's going to be flopping all over the place. It is not going to perform well. So what do you think you're going to do?
Definitely change the back wheel.
Yeah, right. Start cutting. Yeah, and just to, I know we're really getting close to the end. Okay. Yeah. Mallory, how much time do we have?
It is 8:15.
Okay. But, you know, if you're curious, this is terrible when I do this because now you're not having your own experiences. You're watching me have my experiences. Okay. Let's see. See how I did that and how I could wind it up, okay? And so now it has power, okay? you would do things like, I want to show this, okay? If because it's a 5-inch square, okay, do you see how I drew diagonals from one point to the other, okay? And I found the center. All right. And you probably want to, put some tape on it so that it'll, okay, let's kind of see some propulsion. And what I do for the front wheels, okay, is, I can let you take that for homework, okay, is this will push right through real easy, okay, and then here so that you can see what I did, okay, different views, okay, and once you download it and get the chance to read it,
Why do I close my eyes and
I know. 'cause
there
you
we
never
go,
remember.
all right, so cut it off, okay, and then, I almost need a little coping saw. So,
you get a hacksaw?
whoops, no, okay, yeah, all right. You might want to pre-cut those, okay? And now let's get wheels.
Small
Okay.
pitch.
And-
Like,
and,
you
know,
even side cutter pliers.
We were thinking about, maybe pliers?
Side cutters.
Oh,
Side cutters.
side cutters, okay, all right, I'm not sure what
Or I
they
have
are.
some
Limb lopper.
pruning shears that I
shears.
use.
Pruning
Oh,
shears.
okay.
That, you know, for,
yeah.
For
for,
that.
yeah, because
Just
that'd be,
don't let anybody prune their fingers.
But, how do I make holes for a straw and lifesavers? Okay, and so now I have the beginnings of a rover. Okay, so that you can kind of see what I did here. Right, and of course, it doesn't work very well, square wheels. Okay. Have you ever seen square roots? This is a bad joke. Okay. You don't have those kinds of trees around here. Well, gosh, all right, Mallory, help me out. Okay. Trees that grow in swamps, cypress trees. Yeah, and they have the knees. Yeah, right.
Mhm.
Okay.
okay.
I'm teaching math, and I put a picture of it, and I say, look, square roots. Okay, bad. Okay, so you may want to, now you begin to modify this. Okay, great activity. It will keep kids involved. Inexpensive, locally obtainable material. Okay, find some videos, rovers operating on Mars. So if I went to that other website that I didn't show you about, the Mars missions, click multimedia, that means videos, pictures, animations, and you'll find some good stuff. Okay, questions?
Wow.
Oh, good answer. Wow, yeah. You should be overwhelmed, cognitive sensory overload. Now, the cardboard hand that I gave you, okay, how are we doing time-wise, Mallory?
8:17.
8:17. All right, we go to 8:30. All right, let me pull up the activity. Oh, the other one that I like to use on this, okay, is touchdown. These are the two that I like
Those
to
over
do
6
the
points.
best. Okay. And if you look at this one, you're going to have some astronauts land. Okay. So they're in a cabin, and that's what that small paper cup represents. And it's gravity driven, and so you want to cushion the fall. So we'll give you some index cards, and we'll give you some astronauts. Okay, back in 1972, we had 2 astronauts. Okay, the third stayed in lunar orbit. Okay. And as that third astronaut went around, okay, he was about, when you take into account the size of the orbit, it was about 30 miles from the surface, no atmosphere, so we can go, low gravity situation, a sixth of Earth's gravity. About 6,000 miles from the closest human being. Okay. That would get you the Lonely Guy Award. You want to talk about isolation. Imagine being 6 miles away. Okay, and 2 landed. And so now, let's look at the kinds of materials that I would have to give you. Okay, and you can only use what I give you. So, 4 by 5 inch piece of cardboard. Okay. So I'll get these out, okay, for you. And maybe this will be for homework. Okay. A cabin. Okay. Sometimes I'll get hard candy. Okay. And when you drop it, it rebounds and it bounces out. So you want cushion. Some marshmallows, 2 for the astronaut. You could use mini marshmallows, some straws, and some file cards. Notice the cup has to stay open. You cannot cover it. And now I'll say, okay, we're going to drop 1 meter. Okay, we're going to have all kinds of different designs. Those that survive now will go 1.5 meters. And who has the best design that will land safely, and the crew members won't fall out of that cabin. So it's a great design one. Okay, so let me get some file cards. Okay, and so you need 3 index cards. Okay, incidentally, I can vary the size of the cup. I can vary the astronauts from hard candy, marshmallows. One time we had a real smart group. They used masking tape, and they double backed and taped them in.
Oh.
Yeah. Wow. Okay. So you have to make sure that people obey the rules. So you can see that the prep that occurs on this, okay? And I love to use masking tape, okay? And it says, let's see, 3 rubber bands, 8 plastic straws. Do you have to use all the materials? No. Okay.
Subway Eat Fresh.
So, give out 8 straws. 6, 7, 8. Okay, and now, how many rubber bands did it say?
3.
3. All right.
1, 2, 3.
So, there's the materials. And you give them plenty of time. Now, they're working in teams, they're brainstorming, generating ideas, okay? And that's all that they have to go with. You see, you don't want to give them too much, but you, as the teacher, you got some design tips. Okay? Some of the things you can do with the straws, okay, really spreading them out like when a cat drops, okay, legs go out, okay, helps to balance, helps to cushion, okay. Also, when the crew members start popping out of the cup, some people have put straws vertically. Can't cover the top, but I can certainly extend the height. So there's some real tricks. Okay, and you see some just incredible designs.
What are the little marshmallows used for?
Little marshmallows are like
Cushions?
shock absorbers. Shock absorbers. Yeah, I didn't bring in any mini marshmallows. Okay, you set it up the way you want. Okay, and you say you can only use the materials I've provided. You can't use more than this. You don't have to use all of it. You can use scissors. Okay, you kind of cut it up. Okay, and come up with a lander. And it's always great when you can find an awesome movie. Okay, and if I go to the Mars webpage, let me just show you some great resources. Okay, evening. Let's go to the, okay, Explorer Mars, well, that has simulations and game. Okay, Mars Robotics Exploration. Okay, I am going to go and find a movie. So now I'm going to go to multimedia and videos. And there are so many different videos. I'll tell you what my favorite ones are. Let me go a little bit farther. Okay, video archives. There's a whole series of Mars in a Minute. Okay, they're little animated cartoons. Okay, and one of my favorites that I like to use on this is how do you land on Mars? Okay, and let's see, it's 2013. Let me go back to 2012. How do rovers drive on Mars? Oh, that sounds interesting. Okay, so I got something on the rover one that I can use, and is Mars red hot? Okay, but there's one that's called How Do You Land on Mars? But do I give you an idea now how you can search for videos? Okay, let me pull those two up and just play them for you.
It's 8:25.
8:25. Okay, and we stop right at 8:30. What a great way to end.
Yeah.
Okay. So let me search for my Mars videos. Okay, I got them all in one place. The Mars in a Minute one. Okay. How do you land on Mars?
How do you land on Mars? Very carefully. Your spacecraft hurtles towards the planet at thousands of miles per hour, so you'll have to hit the brakes and hurry. First, your capsule needs a heat shield. It protects the spacecraft inside from the heat and friction of entry into the atmosphere. Friction slows you down over 90%, but not enough to land safely. Use a parachute to slow down even more. Still, falling at over 100 miles per hour, you need the right system to land safely. Here are some options. With a small to mid-sized rover, use a cushion of airbags along with retro rockets. Impact at 30 miles an hour and bounce to a stop. With a large lander, use retro rockets and landing legs to touch down, going about 6 miles an hour. Or with a large heavy rover, use a big jetpack to slow down to under 2 miles an hour. Then gently lower it on tables to land on its wheels. Any way you do it, you'll need skill and hard work. There's nothing easy about landing on Mars.
Okay. I have activities where I can use all three different techniques. But this one is imagine a propulsion system and you're landing. Now, Mars has an atmosphere, but it's only 1/100th the atmospheric pressure of Earth. Okay, enough of an atmosphere to contend with it. Okay, Mars is low gravity, 1/3 of a G. The moon is half the gravitational field of Mars. It's 1/6 of a G, no atmosphere, parachutes don't work. Okay, and so we're just dropping it, but just imagine a propulsion system to slow it down to land. So that's that lander one. That other one was it the rovers on Mars? read.
Mars in a minute.
Well, yes, Mars in a Minute series, and I'll be honest with you, I don't know. I don't think I downloaded that one. Okay, it dealt with roving on Mars. Was that 2012? How do rovers drive on Mars? All right.
Magic.
I don't think I have that one in my collection. So let me quickly, okay, here, 4.67 megabytes. That won't take long. Okay, hopefully. Okay, so you want to download them. Okay, they're in different formats.
How do rovers drive on Mars? First of all, there's no joystick for driving a Mars rover. Before a rover hits the road, engineers send computer commands overnight telling it where to go the next day. Depending on how tricky the terrain is, rover drivers have two options. They can send a string of specific commands like drive forward 5 meters, then turn right 90 degrees. The rover turns its wheels enough times to add up to 5 meters, and then turns in place. Or if it looks safe, they can let the rover think on its own. They write commands like, see that rock over there? Find your way there safely. Then, using two cameras like human eyes, the rover gets a 3D view of hazards such as large rocks and steep slopes. After mapping the danger zones, it plots the safest route to avoid them. Either way, did the rover complete its drive as planned? Engineers double check when the rover sends back a postcard of its new spot on Mars.
Okay, so it's really great to come up with some multimedia to go with the activity. It's real world problem solving. I think we need to show this one to our robotics class tomorrow.
Okay.
Yeah, that would be really good because they're busy programming.
It is 8:30.
Yep, okay, all right, good. I know I've run out of time. Okay, any questions? Do you want the materials